The Fibonacci sequence, a series of numbers where each is the sum of the two preceding, presents a universal pattern discovered in Indian mathematics by 200 BC for its application in Sanskrit poetry. As the sequence progresses, the ratio between consecutive Fibonacci numbers approaches the golden ratio, a mathematical constant known for its aesthetic and harmonious properties. This principle not only dictates the 3D structure of DNA, aligning with the golden ratio, but also manifests in human biology and the broader natural world, showcasing the interconnectedness of all creation through a mathematical lens.
It's interesting to note that the diameter of the DNA is 21 angstroms, and if we count the turnings, we will get to 34 angstroms. That's 2 factors of the Fibonacci series. And also, if you look at, there's different DNA. There's DNA B, different DNA A, different forms of DNA. Each one of those actually has a sacred geometry. Sometimes a pentagon, sometimes simply a spiral. There's all different forms of geometry when you look at it head on.
Spiral galaxies form a sacred geometry based on the Fibonacci sequence. And Fibonacci sequencing is not just in the spiral, it's also within us. You know, the length of this part of our finger to the next part of the digit to the next part, these are all phi ratios, from the finger to the palm to the forearm, from the forearm to the bicep, from the arm to the leg, and so on. We have this golden ratio, this phi ratio all over us. You see the same thing in shells and in palm fronds or ferns, in the rose, the sunflower. You see it all over it. It's going to be out there in all the other planets and galaxies as well.
Nature displays a wealth of geometric patterns, hexagons in snowflakes, Fibonacci sequences in flower petals, fractal designs in coastlines, and the spherical shapes of planets. These patterns hint at universal mathematical principles underlying all growth and structure. How might this understanding of nature's inherent geometry lead us to an interconnected understanding that spans from the microscopic world to the vast universe?
When we look at a satellite image of the Earth and we see the rivers and the tributaries that feed into those rivers, and the creeks and the streams that all feed into these from a mountain range onto the plains, for example. When you take that photograph and you look at that, and then you place that next to an image of the root system of a tree, or the branches of a tree, or the bronchial system of the human respiratory system of our lungs, or our circulatory system. If you don't know what you're looking at, you would be very hard-pressed to determine which one is biological, which one is from the satellite, and which image is from a tree or the roots, because the fractal pattern is playing out so beautifully in these images, the same pattern, different levels. So another example of this is when we look at a neuron in the human brain and we look at a bolt of lightning flashing through the sky. Both of them are electricity following preferred pathways, preferential pathways that allow that electricity to express. In the body, it is through the cellular nature of the neuron. In the atmosphere, it is because of the electrical nature of the atmosphere that allows that bolt of lightning to travel.
As an example, leaf, if you look under the microscope and you see the intricate patterns of the leaf, and then you take our skin, the human skin, it looks identical. If you look into the brain neural network, it looks identical to the galaxies and neural networks in the stars as well.
Geometry's impact reaches beyond physical shape and form into the realms of frequency and energy. The flower of life is a prime example, with its multiple overlapping circles. This structure is the origin of all geometric forms, including the Platonic solids,